Okay, our next presenter is Alexander Buyanov. He's DevOps evangelist at Foliage Dev and senior at MTS. Alexander has successfully led the migration of more than 800 developers and over 500 products to new processes and tools. He will talk about the problems that have arisen in big data with the increase in the volume of equipment, as well as what the solutions are. Then we will turn to the experience of solving the same difficulties long before the very concept of big data appeared, and look at possible solutions taking into account this experience.
Thanks
The
a lot.
stage is yours.
Hello, everyone. I'm trying to involve you in some story of programming itself and related with challenges which world give us after everything growing up. And AI ops, for be clear, it's definitely not the ML ops, because I already had that question on my speech today, the previous one. And ML ops is ops specialized for ML, but AI ops is operations profiled by AI. So I'm trying to explain how we going this way. We may call it problems, challenges, whatever you want, and we have too much layers of complexity right now. Systems going more and more complicated because now we have few layers of different developers prepared. It's microservices in modulus. Then we have modulus in our services. Then we have services in applications. And finally, we have the final application for the end user or for an inner user. And it's changed than the previous time when we working only on one layer. We had the application going on the hardware. Then we have operational systems and application going especially on a layer of operational systems. But right now, we don't use this level of complexity. We use the containers, which going on the services of containers, which going on the virtualization systems, on OS, on the virtualization systems, on some cluster systems, on the hardware. So it's changed the way how we try to control it. It changed our mind how we have to live in this world. And the infrastructure take this wave and also changed. We create a variety of data centers and cloud services. And technical stuff and applications which provide this, and the services itself as a product, like AWS or Azure. We also create a lot of specialized hardware like IRM, like GPU, FPGA, specialized for special needs. So we build even hardware for special tasks. We create supercomputers for, now not for so many tasks, but anyway we create it. We create special processors for the mobile phones, for the automobile entertainment systems, and we specialize all of this, even hardware. But after hardware level, we also create a lot of operational systems, which still popular these days. So previously we had just very, very specialized systems, and two populars. Now we have different, for example, in Linux, we have a lot of packages, distribution, I mean. And after this layer, we have a lot of container management systems, have a lot of infrastructure controlling systems, have a lot of styles of infrastructure as a code systems. And this was the answer and the question from industry, because partially infrastructure changed, and we try to change the complexity of systems for working with this infrastructure. Sometimes we change the complexity of systems because our business or other needs, and we have to change level of complexity in infrastructure. And our industry as the developers respond on this challenge by creation 3 different answers. Before, I think, this year, most of companies, most of developers using only these 3 sorts of systems. First of all, it's SIMDB. I don't know, someone use SIMDB right now? No one. Okay, that's old stuff, really old stuff. I really like you don't use it because basically it's from 90s, but still using in big tech and Microsoft also, but in forgotten infrastructure, you know, somewhere there. But it's the systems going from the project and business world. It's the database about which infrastructure we have by documents. So we have this sort of clusters in data center because we buy it. Then we build a few clusters, we put some motherboards there, we categorize it and put by hands in SIMDB. So it's sort of books, but which your accountant use. So that's just looking from the financial and jurisdiction, I mean, low point of view, but it's still usable because of project needs. And the second, it's observability. Someone use observability systems? 1, 2, 3, yeah, really nice. Minimum 4. Glad to hear it. So that's monitoring systems, not only because modern monitoring systems may also do some things, answer on some issues, send alert or do some scripts after some issues, incidents or alerts. So observability, it's most about control, but it's not only about monitoring. So this sort of instruments, looking how it really works right now, it's not from the books, it's from real controlling what your services respond on the any IP, how it looks like from the agents, how it looks like from the operational system. From the different point of views, it gives you a real picture of the real time of your application, of your hardware, of anything. And the third sort of instruments, that configuration management. Someone use it? Yeah, okay, the same guys. I think you're from DevOps teams or infrastructure teams, or you're related with containers or this part. Okay, so yeah, you're my focus group. Sorry others, but maybe later it will be interesting for you because it's also about costs, business, and everything, but I need to involve you in it. And the third sort of instruments about changing real picture of your hardware, operational systems, containers, everything. So Ansible, Chief, and Puppet, the most popular instruments, and they change real time the real picture of your infrastructure, your services, your applications on all levels. So you may type a bunch of text, and then after some time, so right now, it will change on production, and you will see it by observability. If you don't see it, something happened between these 2 parts and something really going wrong. So you may see no one of these sorts of instruments contain the full picture because observability looks like it has everything. But you can control, really control by meaning changing and rule your infrastructure. You can see but can touch. In configuration management, you can touch, but you can see what's happened right now. And you also can understand how it related with your official statement, how you pay for it, which own it, which partner you need to pay it, how law restricted, because you may have databases in EU, and we have regulation about personal data there, but maybe you have the data service in America. And observability and configuration don't have information about it, only CMDB have. So we had, till this year, we had no instrument contain whole three things in one. And it's really uncomfortable because it's not only about instruments, it's also about data set and data mine, because basically in industry, different sort of people, different even teams working with each of these instruments. For example, observability is basically about operations, configuration management is about DevOps or infrastructure management, and the CMDB, it's about project management and part of operations. So we already had this problem in the real past. This you see the Cray one, the supercomputer 50 years ago, and they had the same problem, not the same level of complexity, but they also need to control a lot of microprocessors, put in a lot of motherboards, and in a lot of clusters and a lot of computers. And in one of these stands, they have a lot of layers of their prepared applications, really difficult. And 50 years ago, they find a lot of solutions how to solve it. They prepare queue management systems, still using in high-performance computing. And they find a lot of monitoring systems. We still use the solutions which they find 50 years ago. Why I told you about that? The reason is we can't use their solutions for the last 50 years because their solutions too complicated. It's too expensive to use HPC solutions in our typical development process. Because for this computer, they develop the software on these levels for about 15 years. 15 years for software which will be used on one version of computer. For the next one, they prepare 5-7 years, something like that. So nowadays, we can't spend a lot of times for our basic apps. We need to deploy our application on the production next month, maybe next week, sometimes tomorrow, maybe today. So product managers told you yesterday, but don't believe them. And for the last 50 years, we have solution, but it's too complicated. And last year, we had a lot of releases which give us answer how we may use this solution with 50 years of history, which we're looking for, but too expensive for us, thousands of times more expensive than we can use. So we may use AI, because AI cut the costs. And we put all the information from the something like observability, I explain a little bit later, we combine it with real complex configuration management systems. And we also work with CMDB-like database about every part of our infrastructure from each level, from microprocessor temperature to our final microservices from application on our production. So by AI, we may control it in the thousands of sources, millions of sources, billions of sources, and change it by configuration management style ways in different parts online in the millions of places. And we finally have a solutions, I explained you about 2 of them, which we may use as a CMDB, as a configuration manager, as observability in the one tool, which even product manager or head of DevOps, I'm the manager for a few years, can use by himself, herself, because it have visualizations, it have human-readable infrastructure as a code. It may be customized by no-code style, so you just move the part of your infrastructure and it change online if you have right and access for it. So the two solutions on the market right now, the most interesting. The first one was the foliage. It's my related team doing right now. They released this solution a few months ago. It's prepared for use. It's open source. You can download foliage from Foliage Dev right now and trying to use it. And contact the team. They're really friendly. They may help you. They are oriented to the not the customers, but the community, because it's open source. And for the proof, it's a real topic of the industry. Months ago, Microsoft released the radios. So you also may go to the radios, download it, use it, and you also may combine it. It's too complex, but you may try for choose whatever you want. The radios, for be clear, of course, it's more complicated because Microsoft did it. It's not the startup. But they more oriented, they open for every cloud services. You may use radios in AWS, in Google Cloud. That's available from the box, yeah, like Foliage. But they more oriented to the feature from the Azure, you know, because of Microsoft. But Foliage have no this problem. It's not related with some of cloud services, so you may try it more freely, and they're more open to improve your features because not so many ask the Foliage as ask the Microsoft. So, how it works specifically on different layers? For explanation, I take the scheme of Foliage for some reasons. And you have your levels of execution. Basically, it's Kuber, it's OPI, it's CXL, it's OpenShift, it's anything. Basically, it's anything because you have just a conductor and a driver and IP for working with it, and you may add it yourself or ask the team of Foliage or Radios for edit for you. If many requests will go in, of course, it will be added next release. So then, it go into resource broker and hardware composers. Hardware composers is needed when you need real performance in AI. I think all of you working with AI, and if you're working with real complex problems, you need real performance. If you need real performance, you're working with hardware, partially, but work, and you need to control it by yourself. Sometimes you buy it from the market, but anyway, you have some tips and tricks how to use it, and you may profile it in your tool, AIOps. Then it's going on a few levels. That's just a few of them. You control the power, the cooling, the servers of hardware, and it's combined with how you use the Kubernetes layer. So when you put your performance pressure on some part of your Kubernetes containers, you also may, in one tool, control the cooling of the processors where these containers works right now in the real time. You may control it by yourself. Maybe you want to tweak it, okay, less cooling. You want to forget about fire in your data center, okay, cool it more. And you control it by one tool. And everyone may see how it works and how it changes your echo effect, if you're regulated or you want to be friendly, how it changes your costs, and how it changes your performance. Then you control the user application and other domains, which mean which you may imagine. It's also role groups, it's also reliability, it's also scalability. It's every level which you may imagine always may be used. And then it's all going to the GUI. It's different on the different instruments, and it have different dashboards even in one Foliage. So that's why explanation is so explanation here. So how it works on the architecture level, it's really easy on this scheme. It's really tough to mathematics, to algorithm, but Europe's working with graph theory, which combine the elements and trying to find the right ways to controlling elements, billions of them in one moment, because it's real performance problem. And it also gives you a performance boost because it puts your containers in the near place if they have connection on application level. It's also give your cost boost, not the boost, but the cut. Because of prediction, you may predict when you need more and book this on the cloud services. And also works with infrastructure as a code systems, so it's also based on the configuration management, yeah, but more complicated and more automized. Trying to be on time. What else it gives you? Multi-cloud management. I know right now, maybe for you, it's not so important to work with multi-cloud, but we have only few players on the market which now sell the cloud services. Okay, maybe more. Okay, if you're interested in the area, something like that. Big players which may give you reliability and scalability to the endless. Okay, and they may change the price one day or in 1 minute. All of them, because of new microchips crisis. Or 9 of them may change it, but 1 not because they're located in another country. Or part of them will be regulated by some jurisdiction which you prefer not to use. And each change your costs immediately. You need to move your services from cloud to cloud right now, or you lose billions of dollars sometimes if you have really huge service for the users. And online, you have different costs in different cloud services. And you, like on trade market, by speculating on it, you may have huge amount of money from nowhere just because you move your cluster minute by minute to the less cost. And it's value for everybody on the market because clouds also change the prices online because they have more pressure of performance. That's okay for them. You go on out when they on time and then go to them again. So it's also about reliability because you control how it works, when it works, and you may move it online by canary way, blue-green way, another way, in one instrument where you see everything about your systems on all level, and you may fast recognize the problem when it's going on. You also prevent the bottleneck because if you use only one cloud service, it's bottleneck and you're growing the bus factor. Some days, every systems, every AWS, Azure will be destroyed by some reasons, market reasons, anything, and your service is going by them, but you may prevent it by multi-cloud management itself. AIOps is the most comfortable way for it. It's also universal transferable skills, which mean you growing skills how to work with different cloud services, and it gives you availability to take the best from all of them at the same time. And you take the benefits, every benefits, not only special actions and sales, but some skills for your team and some performance and application boost for your application and product. That's it. I hope I involved in this topic. I hope you will try the foliage dev, and maybe you may try the radius also. If you want to ask me how it works, how you may try, which feature I may add with my foliage dev team, just send me a message somewhere, Telegram, LinkedIn, Viber, WhatsApp, email, everything, and feel free to take coffee with me after the session. And question? Hope I was so clear. That's why you have no questions.
Thank you for such an energetic presentation. It's not easy to be the last one before the coffee break. Thank you so much. Here is a certificate of appreciation for your engagement at our conference. And please take a coffee. Next starts at 12:15.
Thanks a lot. Thanks.